So often we're interested in calculating percentiles, and the notation that we use is P sub k, where the k is the percentile of interest. So for example, if I want to know what IQ score would be considered a high IQ score. So maybe a high IQ score is an IQ score that's in the 90th percentile. So this represents the 90th percentile. And an IQ score that is in the 90th percentile, or P90 or P sub 90, would be an IQ score that separates the bottom 90% of IQs from the top 10% of IQs. So if you have an IQ score that's in the 90th percentile, you're pretty smart because you're in the top 10% of IQ scores. Okay, so let's take a look at an example here where we have a relatively small sample and talk about how you calculate percentiles for values within an actual sample. So here we have 20 random individuals' IQ scores, and the first thing that you want to do is order your data from least to greatest. So now let's take a look at question A, where we want to find the percentile for an IQ score of 103. So in our data set, you're going to take a look at where 103 first occurs. So I'm going to mark it there in my data set. Now, to calculate the percentile for an IQ score of 103, I hope you can see visually from this number line here. So I've organized our data into a number line here from least to greatest, that 103 is kind of in the top of our set, right? Okay, so I want to figure out what does that mean when I say top of my set? So we're going to calculate the actual percentile for that IQ score. And to do this, there's a simple formula. And this formula actually makes a lot of sense. So if I want to find the percentile of a value, and let's call that value X, then what I'm going to do is I'm going to count to see how many values are less than that value of interest. And then I divide it by the total number of values in my data set, total number of values. So basically you're dividing by n. And here we have a proportion or a ratio. And if we take our proportion or ratio and multiply it by 100, we get a percent. So in this particular problem, let's count to see how many values are less than 103. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There are 13 IQ scores that are less than 103, and that's 13 out of 20 IQ scores. So, and then let's multiply that by 100. So that means that an IQ score of 103 is in the 65th percentile, okay? So the 65th percentile means this IQ score of 103 is P65. It separates the bottom 65% of IQ scores from the top 35% of IQ scores. So an IQ score of 103 would be considered a relatively high IQ score, right? Okay. Now, what if I want to ask the inverse of question A? So instead of starting with an actual value and figuring out what percentile it is, what if I wanted to know what IQ score is in the 25th percentile? So I want to know what IQ score separates the bottom 25% of IQ scores from the top 75% of IQ scores. So there is a formula for finding that value when you have a sample or a set of data. And if you follow along in your textbook and in the handout, I've given you a flow chart that includes this formula. So L, which represents the location or the locator that gives the position of the value that is in the 25th percentile. To find that position in our set of data values here, you would take the percentile of interest, which we call K, and then you divide that by 100, so that gives us the percent, and you multiply it times your sample size, and that tells you the position. However, if L is a whole number, okay, so if you do use this formula and L is a whole number, you're going to follow the flow chart. The value of the kth percentile is going to be midway between the Lth value and the next value in your sorted data set. So we're going to find that, that midway point by adding the Lth value and then the next value and then dividing it by 2. Okay, now if L is a decimal, so if L is a decimal, what you're going to do is you're going to change L by rounding it up to the next whole number, and then that becomes the position that, that you're going to look for. Okay, so this is what I mean. So here, the percentile of interest is 25. So to locate that, that's going to be 25 over 100 times n, which is 20. And here, when we do that, that gives us a whole number, which is 5. So this is saying, look at the fifth position. So the IQ score that sits in the fifth position. But because this is a whole number, so I'm going to use red here and count the fifth position. 1, 2, 3, 4, 5. That's 89. So I have to find the IQ score that is midway between 89 and the next value. So the next value is 95. So to calculate that, I'm going to take 89 plus 93 and divide it by 2. And so that tells me that that is an IQ score of 91. So, right, this means that an IQ score of 91 separates the bottom 25% of IQ scores, okay, from the top 75% of IQ scores, okay, making 91, right, the 25th percentile, okay? Okay, so in green here, I will mark right here that this is an IQ score of 91, and that IQ score of 91 separates the bottom 25% of IQ scores from the top, right, 75% of IQ scores. And this makes a lot of sense. So if you take a look, how many IQ scores are below an IQ score of 91, we can count that there are 1, 2, 3, 4, 5 IQ scores less than 91. So that's 5 scores out of a total of 20 scores. And so that makes up 25%. And then if we take a look at how many IQ scores are above 91, well, we have 20, and if 5 of them are below, that means 15 of them are above, so that's 15 out of 20, which gives us 75%. So that makes sense that an IQ score of 91 is in the P25, or the 25th percentile.